Hey, everyone. My name is Greg. This is Edson. We're going to talk about how to build a Bitcoin dApp using chain signatures. This is the basic architecture. All of this happens on the client side. And essentially, we use Bitcoin.js lib to create a Bitcoin PSBT, which is a partially signed Bitcoin transaction. We use that to get the transaction hash, and we pass that transaction hash to the NEAR MPC and get the signature for that Bitcoin transaction back. And then the dApp calls sign input async, finalizes the Bitcoin transaction, and then it broadcasts that signed transaction to the Bitcoin network. This is a demo of the app working. See, it's signing with a NEAR wallet. It's getting the signature back. And then it broadcasts the signed Bitcoin transaction to the network. You can see here, this is the successful Bitcoin transaction right here. And I'm just going to go through the code, the lifecycle of the transaction. So this is a normal React form. This calls the get and broadcast signature. So right here, this is where it constructs the Bitcoin PSBT. And it first gets all of the Bitcoin wallets UTXOs, and then it assigns all of the inputs and outputs of the Bitcoin transaction. And then once we have a partially signed Bitcoin transaction, we call the get signature. And so the way that we're doing this with Bitcoin.js lib, we need to pass in this key pair and this sign function that calls the NEAR sign function. And so this is the sign function on NEAR. It just constructs the transaction, and then it calls the wallet.call method. And so this is what pops up the NEAR web wallet. And so that returns the signature. And once we have the signature, we call this broadcast function with the signature passed in as a parameter. And then we construct the PSBT again, and we pass in a sign function that already has access to the signature and returns it. And after that, we can call PSBT finalize all inputs, and we broadcast the transaction to Blockstream, which propagates the transaction to the Bitcoin network. And that's it. So that's how you can build a Bitcoin app using chain signatures with all of the code running in the client. And Edson is going to explain how to do the same thing, but with a smart contract.
Hey, hi everyone. Like Greg mentioned, we can do the same. Looking at the architecture of the app, the client is doing basically gathering the UTXOs, but connecting with the MPC network to get the signature, and then constructing everything in the client side. However, here we have a different architecture for the app that is just gathering the UTXOs, but then is communicating with a NEAR contract that internally is calling the MPC contract that is connected with a couple of with the MPC network. So you basically can, from the client side, simply gather the UTXOs, execute a NEAR transaction that is calling a NEAR contract, and this NEAR contract will build the transaction payload, connect with the MPC contract, get the signature, and return everything to the client side that is ready to be broadcasted to the Bitcoin network. And yeah, that's we believe this pattern is very powerful because it could enable more complex logic that it can generate basically that is going to be executed within a NEAR contract. Now for this, basically if you want to start building this type of contracts, we have prepared for you what we call the OmniTransaction.rs, which is basically a library that allows you to create transaction payloads, but not only for Bitcoin, but also for NEAR and for Ethereum inside a NEAR contract. You can visit the repository in NEAR/OmniTransaction.rs. And here we have a bunch of, a couple of examples. But here also we have more elaborated examples. For instance, for Bitcoin encoding, Bitcoin signing for legacy and SegWit transactions. And we even include examples of how to propagate that to a Bitcoin network. And yeah, that's pretty much all.